the system. So one of the themes we've talked about is how bones have a tremendous blood supply. Right, there's a lot of blood in a bone. This system of blood vessels and the conduits that go to serve them it's called the Haversian system, Haversian, the Haversian system. Man, why do they have a screen that doesn't fit the... Makes no sense. All right, well, anyways. And the Haversian system is basically this vast network of communicating channels that passageways, channels, and the canaliculi, you guys remember that term maybe, that have arterioles and venules and then capillaries coursing through them. So the way the blood gets into a bone is through what's called a nutrient foramina. Foramen, F-O-R-A-M-E-N, foramen is the singular for a hole in something, usually a bone, and foramina is the plural. All right, so foramen and foramina, the nutrient foramina. These are holes in the outside of a bone that allow for these blood vessels to enter. And then the nutrient foramina branch into what are called perforating or Volkmann canals. In general, I don't use eponyms, so names of things based upon some dead white guy, but I will mention them so in case you ever run across them, you know what it means, all right? And then these perforating canals come and they will connect up with some sort of central canal. The central canal is just a tube that runs longitudinally along what are called osteons. And we'll see, here's a picture of an osteon here. We'll see more pictures of them in a bit. So there are, you'll notice on the decks in front of you, Annabelle and Vicky have done a wonderful job putting out the microscopes. I'm not sure if there are slides out associated with them yet or not. They're working on that, but there will be, if they're not soon. Anyways, I'll be showing the pictures here, and you'll have some free time to look at the slides. Certainly, in the past, I often have used a picture of ground bone, a piece of bone, and helped and had students identify it. So when we're looking at this section of bone, it's made up of many osteon that are packed together. And I'll go through this model later in the lecture, but you can see it here where this is one osteon that's been drawn out. Here's another. There's like many of them bundled together in the course of forming a dense bone. All right, what else do I want to say? So this is dense bone, or also called compact bone, and then there's spongy bone towards the marrow cavity, and this is made of these little spicules of bone, little like fingers of bone that form this broader network called trabeculae. So trabeculae is related to the in the Latin to the root word that from which the word tribulation arises. So trials and tribulations, or a tortuous path, meaning this like very convoluted network of bony spicules that runs throughout the marrow cavity of the spongy bone. When we look at an actual osteon, one of these sort of bundles, you'll see that there are these layers, these rings, like in a tree. And each of these rings is a lamella, another word for layer, and they're concentric to the central canal. So these concentric lamella that radiate out around the circumference of the osteon. We see these dark spaces here represent the lacuna with the osteocytes inside of them. Lacuna, again, is just a void space. And radiating out from them, these little finger-like, hair-like projections, those are the canaliculi. Canaliculi. Along the outside of the compact bone, or around the outside of the entire shaft of a long bone, for example, you are going to have circumferential lamella. They're running the entire circumference of the bone. Do not be confused between circumferential and concentric lamella. Concentric lamella are concentric to the central canal in a single osteon, whereas circumferential lamella run the entire circumference of the shaft of the bone. Only other thing that we have here are the interstitial lamella. The interstitial lamella, because these osteon are not hexagons, they're circles, they don't pack perfectly together. In the little leftover spaces between packing these like cylinders together, we'll fit in these interstitial lamella into the interstices, as it were. All right, everybody cool? So there's that. You can label that at your leisure. Okay, so there should be two of these models. I don't know. I see one on the deck. I'll find the other one, but there's at least one right here that I pulled up earlier. Okay, so in this model, we can see the here's an osteon, here's another osteon. In this model, these little white bumps are meant to represent osteocytes. The void spaces are meant to represent the lacunae. The red painted in here is meant to represent blood that is getting into that area near the osteocytes through the canaliculi. Here's a perforating canal going into the conversion system, central canal. If we were to draw out each of the layers, each of the concentric layers, concentric lamella of an osteon, you would notice that there is this pattern of collagen fiber deposition that runs cross-cut to one another. They sort of are spiraling around in one direction, and then that's at a 90-degree angle to the fibers in the layer below it, and so on and so forth. All right, so it's sort of reinforcing strength throughout these concentric lamella, circumferential, or concentric lamella, yes. At the ends, you can see we've drawn out some of these circumferential lamella that are running along the outside. And then on the very outer margin of the bone, we have this periosteum. That is the cellular and fibrous layer that I talked about yesterday that lays on the outside of the bone. This is where we have osteoblasts, osteoprogenitor cells that maintain the bone density. Was that everything? I think so. Yeah. All right, there's the unlabeled model. So the same model, looking at it from the side. Is there anything new here? I guess not. Same stuff, different view. You can go through that at your leisure. So here is what a typical bone slide may look like, of course, without the labels. And you can see here, this would be a central canal. This would be an osteon. Each of these would be a concentric lamella. All these fine hair-like structures here are the canaliculi. Yeah, I think that's most of the features on that slide. Okay, moving onward and upward to the macroscopic realm. There are 6 types of bones. These are long bones, are the most common. And these are what act as levers, rigid levers for body motion, acted upon by the muscles. Then we have flat bones. So many of the bones in the cranium are flat bones. For example, there's the parietal bone of the side wall of the skull. And their principal job is protection of the important stuff inside the brain case. Next are sutural bones. And the story I have to tell about that skull is actually about a sutural bone. I really do want to find that skull and see if I can tell the story. It must still be up in the attic someplace. But sutural bones, so a suture is a place where two bones, it's a syndesmosis, where two bones knit together to form a continuous plane of bone. So, for example, between the occipital bone and the parietal bone, we have the lambdoid suture in the shape of a lambda. And sometimes, not always, in fact, in most people not, but sometimes you'll find a spurious bone that was not, that's not found in other people, but somehow resides like a little island living inside the suture of between two bones. So sutural bones. And there's a pretty interesting story. I'll tell it in a bit when I get further down the road. There is then irregular bones. And irregular bones have weird shapes. Vertebra are excellent examples of those. The sphenoid is another irregular bone, very weird shaped bone. Short bones, such as the carpal and tarsal bones. These are the bones of the wrist. I decided this morning over my bowl of flakes that I was going to cut the names of all of them out, so we're not going to learn that. And then there are sesamoid bones. Sesamoid bone. The funny thing about there's only a few sesamoid bones that everyone has. Sometimes there are sesamoid bones that a person has that not everyone has. They're called sesamoid bones because often they're teeny tiny, like a sesame seed, very tiny. And it's odd that the one example I have up here is of the one enormous sesamoid bone, which is the patella, the kneecap. So a sesamoid bone is a bone, by definition, is a bone that is entirely encased within a tendon. All right? The patella is entirely encased within the tendon of the femur, the femoral tendon. Comes down off the quadriceps, surrounds the patella, it's the patellar tendon, and then attaches to the tibial tuberosity, which is that bump on the top of your shin right there. Okay, and this is where, so the quads are what they help flex the hip a little bit, but mostly they do the kicking action of the foreleg. All right. So a sesamoid bone is a bone that's entirely encased within a tendon. Some other examples are the pisiform. So the pisiform bone is a bone that if you take your hand and you go on the pinky side of your hand down to the corner of your palm, right where that tendon comes into the palm, you'll feel, particularly if you flex the wrist, you'll feel a bone in there that you can kind of move around. That's the pisiform bone. It gives you mechanical advantage over that tendon when you're flexing that wrist. It's a very small P-shaped bone that doesn't directly articulate with anything. It's just contained within that tendon that is there in the wrist. That the pisiform is another sesamoid bone. But there are other ones. People can get sesamoid bones in any tendon that you may have it, but he may not, or whatever. You know, it's just pretty random. Okay, so there's that. All right, so just some general terminology about a long bone. So we have the living bone on the left and the dry bone on the right. Along the let's start with the dry bone. There are three regions in a long bone, there's going to be the proximal and distal epiphysis, and then the diaphysis in between the two of them. So the epiphysis is going to be where the articular surface of the bone is, and the diaphysis is the long shaft of the bone. All right, and you can see that there is this line of bone that separates the epiphysis from the diaphysis. We call this the epiphyseal line. Oh, so here it is labeled, the epiphyseal line. Does anyone know what that's called in common parlance? What do you call the epiphyseal line? Yeah.
Growth plate.
That's your growth plate, right? That's the growth plate. I decided to cut out how bones actually grow, and form and grow, etc. But essentially, it's going to happen by, this is an osteoid plate. It's like sort of like cartilage. It's an osteoid plate of uncalcified matrix that has these osteoprogenitor cells that are building new bone, and the bone lengthens off of that growth plate. And then when you've finally grown, then it seals over. But the problem is, as you're growing, it's a point of weakness in a bone, and if you break a bone there, it can hinder the future growth of that bone. So it is a point of weakness in the bone during growth. All right, so then we have compact bone, spongy bone, and the marrow cavity here. So nutrient foramina, the periosteum surrounding it. So this is a picture of a femur here, and a femur in the adult, not in the child. In the child, it's all red marrow. But in the adult, it's only the proximal epiphysis that has red marrow in it. The rest of it has been replaced by fat, which is yellow marrow. Red marrow is where red blood cells are made. It's where erythropoiesis happens. All right. Okay, so axial skeleton is comprised of the skull, the vertebral column, the ribs, the sacrum, and the coccyx. And there are this is probably not news to any of you, but there are three types of vertebra. There's the cervical, thoracic, and lumbar vertebra. And then on the front here, we have the costal cartilages. Costa just means rib. Costa is another word for rib. The costal cartilages are attaching the bony part of the rib to the sternum. And we'll go through the parts of that in a little bit. The skull. So when I was in medical school, when I was in Dr. O'Malley's anatomy class, he used to talk about, and I wish I was half the anatomy professor that guy was. Incredible. But he used to say that there's as much anatomy above the neck as there is below the neck. And he really that was not hyperbole. He's correct. There's an amazing amount of anatomy in the skull. It's an incredibly complicated part of the body. And I always have only done a small subset of it, but I've made an even smaller subset this year, so you guys can maybe breathe a little bit of a sigh of relief when it comes to that. Sorry, Vicky. You guys had it worse last year. But here is the skull as an overview. It's made up of two regions, okay? There's the brain case, otherwise known as the cranium. These are the bones. So bones of the cranium are all bones that in some way form part of the wall that contains the brain, all right? So there's a subset of bones that are somehow making the compartment that the brain sits in. And then the rest of the bones in the head make up the face. In other animals, we call this the rostrum. like the snout, the rostrum, but in humans we just call it the face, the facial bones. In the brain case, we have the frontal bone, the parietal bone, the temporal bone, the occipital bone, sphenoid, ethmoid bones. We'll see them all in a little bit more detail. And then there's the lacrimal bone, the nasal bone, the zygoma, the maxilla, vomer, and mandible. That's how you say each of those words. So the frontal bone is so named kind of obviously, right? Because it's in the very front of your face, in the front of the head. The parietal bone, what did I say the word parietal meant yesterday? Wall, yeah. So the parietal bones just form that wall along the sides of the brain case. The occipital bone, the occiput, is in the very posterior portion of the brain case. Why do, what word do you see in this word as you see it here? Why do we call it the occipital, I guess what I'm asking. What words do you know that start with OCC?
Occidental.
Are there two C's in Occidental? Yeah, no. Go with the double C. So, what about the word occlude? Occlude, OCC. Same word origin. And what does it mean to occlude something? It means to hide it from sight. Hide it from sight is to occlude something. OCC, LUDE. Well, the occipital bone is the most hidden from your own sight. All right, that's why it's called the occipital bone. So it's your eyes are over here. The occipital bone is fully occluded from your sight. Not that I can see my sphenoid bone or something like that, but the other thing that's ironic about it is actually the occipital lobe of the brain is the visual cortex. It's the part of the brain that processes visual information. But they didn't know that when they named it the occipital lobe. Then the temporal bone. Why, oh why, do you think they call the temporal bone the temporal bone? Anatomists. It may seem like they name things randomly. They never did. They never do. There's always some sort of reason for why they give something a name. And it's usually descriptive. It's usually descriptive, and you have to just get inside their head and think about why they chose that name. Temporal. What does the word mean in general? You're at you're at dinner with someone, you're on a date, and your date uses the word temporal. Maybe they're trying to impress you or something like that. What are they talking about? Time. Yeah, time. What does this bone have to do with time? Can anybody guess? Oh, you young scholars, so unmarred, so in the flower of youth and unmarred by the ravages of time. Eventually, you're going to get older, and as you do, your hair will gray. Where does it go gray first? Right here on your temples. This is why we call it the temples. Why we call it your temporal bone. Your hair goes gray. I mean, I have like a half dozen gray hairs or so here on my chin, and eventually it'll crawl its way up my beard and get to my sideburns, and then eventually to my temples. They thought that this was where you show the first signs of time. Your hair grays first, right here above the ear. So we call it the temporal bone, and which is why they're called the temples. Sphenoid and ethmoid. That might. I looked those up once, I remember. And I also remember them not being an easy story to tell. Oh, come on. But lacrimal bone, what does the word lacrimal mean? You guys know that word? Anyone, is there anyone who's a fan of opera in the room? Am I deluding myself? Yeah. A lacrimosa is a song of wailing and tears. So lacrimose means tears. The lacrimal bone, you can see the tear duct that will pass from the corner of your eye through the lacrimal bone into the top of the nasal cavity. That's why they call it the lacrimal bone. The zygoma, we'll get to the zygomatic bone later, and the maxilla mandible in a bit. Yeah, because there's a better picture for you to understand why they call it the zygoma. All right. So, what do I have to show here? We have the occipital bone. We have the lambdoid suture, so-called because it looks like the Greek letter lambda, like the triangle or whatever. And the sagittal suture running between the two parietal bones along that mid-sagittal plane. Yeah, we'll get to the squamous suture. We have a better view of that in a bit. So I'll tell the story. I'm going to find the bone. I'll tell the story some other time when I have the skull in front of me. It's a good story. It's a crazy story. Actually, it relates to the football team. I don't know where that football player is. Where's Walter? Is he in here? He'd skip out to go to practice or something. All right. Yeah, so here's the sagittal suture that runs down the midline. The coronal suture, shoot, I might have forgotten to talk about that. Did I talk about coronal sections yesterday when I was talking about the planes? So when you're taking planes, that frontal plane is the one that goes front to back, right? But when you're doing it in the skull, and only in the skull, we call them coronal sections. Because it's going along the coronal suture. What does the word coronal mean? What's that? Crown. Thank you. Yeah, it goes through the crown of your head. So this is the coronal suture, the sagittal suture, the lambdoid suture. And I guess you can see that it looks like a lambda more from that direction. The way I had it before, I guess it looked like a delta or something. All right, let's keep on trucking. So here's the temporal bone, and the last suture is this one called the squamous suture. Squamous suture. Now, when do we run into that word? Squamous. When did I use that word? Epithelium. And what did it mean in relation to epithelium? Squished. Great. So for all of you that I gave an actual real skull to, and you can even try it with the plastic ones, I don't know. Please remove the calvarian. The what? That's the top of the skull. Remove the calvarian. And then take your skull and gently hold it up to the light, up to the light of the window or up to the light of the screen or something, and look through the temporal bone. Hold that up. You should be able to see light passing through the squamous part of the bone. You hold it up to a bright light. Maybe you have to come over here. Let's see. Bring it over here, Tom. So let's see. Oh yeah, yeah. Hold that up right here. No. You see that? Yeah. Very thin. Very thin. That's the squamous part of the temporal bone. If you can't see it, you should come up here and point it at that glaringly bright light right there. But you can see light shine right through the bone there because the bone is incredibly thin right at the squamous part of the temporal bone. And because of that, because of this being squamous part of the temporal bone, we call that the squamous suture. All right, this is a good place to talk about the zygoma. So your cheekbones are part of the zygomatic They come from the zygomatic bone. The word zygoma comes from the Greek, and it means yoke. Yoke, as in to yoke some oxen together or something like that, right? And not like as in an egg yolk, Y-O-K-E. And it truly does. It yokes the whole face and skull together. It's the yoke that holds the two oxen together. The facial bones and the cranial bones are yoked together by the zygoma. It attaches to the temporal bone, it attaches to the sphenoid bone, it attaches to the frontal bone, all of the cranium. It attaches to the lacrimal bone, to the maxilla, and maybe some palatine bones. I don't know what else it attaches to in there. But it's the yoke that holds one group of bones in the head to the other, the yoke, the zygoma. So the zygoma forms the zygomatic arch. The zygomatic arch, that's the little ridge. So this is like, your cheekbone is the point here, right? But then there's this line that runs back towards your ear. That's the zygomatic arch. And the temporalis muscle that helps you chew and whatever, that dips down behind the zygomatic arch and inserts on the mandible. The zygomatic arch is made of the temporal process of the zygomatic bone and the zygomatic process of the temporal bone. What? It's a little confusing. It's just, what bone are you in? Then name the other bone. That's the process, right? So zygomatic process, temporal process. They form the zygomatic arch. I left the styloid process in place on this list because the styloid process, it's interesting in that it attaches to the hyoid bone. I don't have a picture of the hyoid bone yet, but you can find the hyoid by taking your hand, and it's this bone right here, that's wagging right here on this model, but you can take your hand and go right into the angle of your throat, and you can feel that bone that's way up in the crease there, and you can actually move it side to side. It's kind of weird. That bone is attached by a muscular sling to this styloid process. It's what prevents us all from looking like Newt Gingrich or something like that. Like, it keeps everything tucked up in there, right? The styloid process is an interesting thing because you have a plastic skull right there, I believe, right? And the styloid process is there. Do any of the people with actual skulls have the styloid process? I would guess not, right? Because the problem is, if you disarticulate the mandible, the lower jaw, and then take a real skull and set it down, first thing to go is that styloid process. It snaps right off. So most real skulls that aren't very carefully cared for have that styloid process snapped off. Yeah. And so if you ever come in contact with a human skull somewhere, like, I don't know, whatever, they're out there, and it will affect the value, the relative utility and value of that skull, and it'll say something about how it was handled if you notice that the styloid process is actually gone. It's also significant because the styloid process is a really important anatomical landmark. So I talked about relationships, anatomical relationships, establishing relationships. I'm not going to. This morning already, I deleted all of the questions about the different foramina in the skull. There's like a zillion holes in your head in the bottom of the skull. If you turn the skull over and you look at the bottom of the skull, you'll see, holy crow, there's about a zillion little holes under there that do all kinds of stuff. Yeah, sir.
Is there any way to tell it?
Yes, there are. There are some, but that is a statistical difference, and so does not. I think it is harder based upon a skull to say absolutely whether it's a male or female than based upon the pelvis, right? The pelvis is very easy. There are statistical differences amongst the population, but there's wider individual variability between a male skull and a female skull. All right. Yeah, I mean, there's just physiognometric differences in the general shape of a female skull, but that is more widely variable. And you can think about that in terms of how widely varied people's faces are, right? Facial variation in the human population is really wide, whereas the variation through the rest of our bodies is less so. Okay, so what's new here? Yeah, some stuff. Nasal bones. This thing here, this like green bone that's really weird and hard for me to point out, is called the Ethmoid Bone. The Ethmoid Bone. It is a very important bone that we're actually going to learn a number of the parts to, but it's hard to display without the skull being blown apart. It's not out. I don't know where it went. Remember there's that box, the big long wooden box? Is that still downstairs? Remember the one that had a whole skeleton in it?
Yes, that is.
Okay. If you wouldn't mind, I would appreciate that. So I have a disarticulated skull that has all the little bits and bobs in it. And we'll be able to see them, and I'll show pictures about the ethmoid in a bit. Then there's this, part of them are these nasal concha. The superior, which you can't see here in the middle, and then inferior nasal concha. The inferior nasal concha are separate bones. They're also called the turbinates because their job is to make turbulence in the air that you breathe in, so that the crap that is in the air gets stuck to the walls of the mucosa in your nasal passages. Also called concha because it looks like a conch shell if you were to cut a conch shell across. Maxilla. Okay, so these are the mental foramen and the mental protuberance. I remember I said yesterday your chin is called the mentis. The superior and inferior orbital foramen. So you can take your fingers on your own skull and press in and find them. You can find where they are. My superiors are right here, and my inferiors are right here. You can feel the little dimples in your bones if you dig around for it. That's nerves, these neurovascular bundles, or VANs, vein, artery, nerve, is going to come out of those holes, right, and supply the sensory and blood supply to the face. Oh yeah, thank you so much. I really appreciate it. Okay, we'll get into this guy in a minute. Yeah. So let's see here. The inferior aspect of the skull. So you can follow along with your skulls that are out there if you want. Next year, I'm going to buy a skull for everybody in the class. You can just take it home for the month. So the first thing you see is this giant hole in the head here, the Foramen Magnum. What's that for? What do you think that's for? Spinal cord. Foramen Magnum, the magnus, the large hole in the head. Adjacent to it are these occipital condyles. So we're in the occipital bone. A condyle is an articular surface. It's a surface that has cartilage on it. What do you think articulates there? When I say articulate, I don't mean able to express myself eloquently with verbiage. I'm talking about where two things connect. So articulation, like being an articulate person, means you're your mind and your tongue are able to connect with one another. But anatomically here, it is where two bones connect with one another, right? So this is where the first vertebra, C1, is going to attach. It has a special name. We'll see it in a minute, but I'll just say it now. It's called the atlas. The atlas is the name of C1. I had, previous to about 8:30 this morning, had you guys name each of these holes, foramen spinosum, foramen lacerum, the jugular foramen, the carotid canal. There's a number of them. Pterygopalatine plates, but all that stuff has been washed away. I'm not going to have you guys hold to it. The other hole that I want you to know, so there's the foramen magnum, and then the external auditory or acoustic meatus. You'll see that in the side. What do you think that's for? Can't hear you, please. Huh? Hearing. Yeah, that's for your ears. That's your ear hole. Acoustic meatus. I think that's everything. Okay, let's look down the middle. So here we begin to see the ethmoid, and this is why. So I want to talk about certain bones. You're not learning everything about every bone. I'm teaching you features of bones that I'm going to reference later when I talk about sensory stuff. Okay. So the ethmoid is important because there is. Let's pull out an ethmoid. What? I'm missing an ethmoid. Well, that's not. Well, I don't know. I'm not going to go digging for it. But the ethmoid bone. No. Has this special spot at the front of the brain case, in the anterior portion of the brain case on the floor. And it has this crest that comes up here called the crista galli. Does anybody habla español? A little bit? No? No one? Well, anyways, it's the cock's crest. All right, so it means like chicken's crest or whatever. The crista galli. And then on either side of it, we'll see a better picture of it. There's this thing called the cribriform plate. These are where the olfactory bulbs rest, and then send down these little perforating fingers of nerves that enable us to smell. All right, that's the ethmoid. This is the sphenoid bone, a crazy shaped bone, very irregular shaped bone that looks like a bat or a butterfly or something in the center of the brain. Extremely complicated bone we're not going to really touch too much. There's a number of sinuses. So transecting the brain, we can see the sphenoidal sinus. We're not able to see the ethmoidal air cells because it's been cut away. Frontal sinus. The maxillary sinus is also not visible here. But there are various sinuses or air spaces in these bones. These give our voice the sonority that it has. All lined with mucosa. So here, on the temporal bone, we see the internal acoustic meatus. This is the ear hole on the inside. All right, this is how the nerves that are going to serve our inner ear get out of that part of the bone to the brain through the internal acoustic meatus. I think that's all I want to talk about there. Okay, yeah, I really stripped this slide down. There were a lot of features on this slide that I pulled away. But you can see here the cribriform plate has this, on either side of the crista galli, there's going to be these two bulbs that sit there, and that's where our sense of smell is going to come from. Yeah. Okay. So a couple more statements about the temporal bone. Here's the temporal bone in isolation. I do have a couple of these. So who wants one of these? Nobody jump up at once. Who wants one? Got it. Anyone else want one? Sure. Okay. These are the temporal bones. And I'm going to tell you about this one because maybe when you guys are in medical school, some of you, you're in a cadaver lab and you're doing your dissection, you've done the calvarectomy, the neuroanatomy prof has come in and made you take out the brain and stick them in a jar for next semester. And you're poking around inside the brain case and you have to name this and that hole, whatever. And then you're like, oh, I can't wait to see the inner and middle ear. And the prof says, no, we're not going to do that. That's a pain. And you're like, oh, you're crestfallen. I'm about to tell you how to do it so you can do it anyways and be the only person in the lab that's done it. Because it's worth doing. It's really cool if you do it the right way. So this bone right here is the temporal bone in isolation. We're looking at the inside of it, and this would be on the right one because that's the anterior. All right, so here's the squamous part of the bone. Then there's this big, like almond-shaped part of the bone. The people I gave it to, you can identify it there. We call this the petrous part of the temporal bone. Petrous. Does anybody know what the word petrous means? What's that?
Stone.
Stone, yeah, good. Good job, yeah. So, like for example, in the Bible, you are Peter. You will be named Peter because you are the rock upon which I will build my church, or saltpeter, rock salt, right? Petrous means rock. Why would they name this bone the petrous part of the temporal bone? Well, it's hard like a rock. It is, in fact, the densest bone in the body. Why, oh why, might your body want this particular bone to be the hardest bone in the body? Because the three smallest, most delicate bones in the body live inside of it. Your inner ear lives inside of the petrous part of the temporal bone. The way to reveal it is you just take a little bone saw, one of the little things, and you just make a little score here, you make a score here, you take rongeurs, which look kind of like big wire cutters, you stick them in either groove on either side, and very gently, just so gently, you go, and the whole top will pop off of that, and you'll see the whole thing laid out like a Sunday birthday cake right in front of you. So beautiful. Yeah, it's worth doing. It's not really that hard, and it's not in most dissectors. So maybe you'll remember. Think back on my poultry offering to you. All right. Anything else here? Nope. Seems like that's all redundant. Sphenoid. You know, it's funny because I had this slide and there were like 5 million labels on this slide, and I took them all away. So it's just like, yep, that's the sphenoid. There it is. Super complicated bone. This is the anterior view of it. This is the back of the orbit. This is the superior orbital fissure, foramen rotundum, optic canal. Doesn't really matter. Okay, here's the ethmoid. Here's that ethmoid. This is the top of it. And we can see the crista galli here, the cribriform plate with all these olfactory foramina, these little holes that the olfactory nerves are going to go through. And then you can see these ethmoidal air cells, which are the sinuses back in the ethmoid. Here it is from the back side. And we can see here, that the superior nasal concha and the middle nasal concha are actually parts of the ethmoid bone. All right, these are the palatine bones. There's the hyoid bone. Really just need you to be able to identify them, that's all. Sinuses, I kind of talked about them already. I don't want to waste too much time. The vertebra. What do I want you to know about the vertebra? You know, the only thing I really care that you know about with the vertebra is to be able to identify the atlas and the axis. So I've got, here we go. Here's an atlas and here's an axis. The atlas is the first vertebra. Why do you think they call it the atlas? Yeah.
Holds up your head like Titan.
Yeah, that's right. That's right. The Greek god, the Titan. That's right. So the atlas holds up your skull, and then the one below it is called the axis. Does anyone want to guess why that? It acts as the axis upon which much of the rotation in your neck comes from. Right? There's one part. So when you look at the axis, the atlas, it has a very distinctive look. It doesn't really have much of a body at all. It doesn't have much of a body at all. It's really just acting as a support structure that then is resting right on this dens. And then when you can see that the axis rotates around, the atlas rotates around the axis of this dens, which is right below it. The dens means tooth, right? It just means tooth. So when you look at the atlas, you can see this sort of toothy projection sticking up out of the top of it. Right? Sort of specialized vertebra. Who wants those? All right, I really don't care about you knowing the parts of the vertebra otherwise. Sacrum, coccyx. All right, here's the rib cage. I'm almost done. Manubrium, so the sternum has three parts, the manubrium or the handle. All right, manual meaning handle, the handle to the knife, here's the body. And then xiphoid, referring to blade. So they thought of the sternum as a dagger. Yeah, I don't know. It's the way they saw it. There are 7 true ribs, and then ribs, last 5 ribs, 8 through 10 are called the vertebral chondral ribs, meaning that they don't really connect directly to the sternum. They connect to the costal cartilage below it. So you can see 7 goes right up to the end of the manubrium, the body of the sternum. And then 8, 9, and 10 are vertebral chondral. The cartilage attaches to 7. And then the last couple are your floating ribs that are way in the back. And they're not actually attached to anything. They're just floating back there. Very easy to fracture those and break them. Don't do that. So, clavicle. One thing about the clavicle, there's 2 ends. There's the sternal end that's medial that attaches to the sternum, and then the acromial end that attaches to the acromion. That's important because that's where you have AC separations. The word clavicle is related to the word claves. I guess we established there were no Spanish speakers in here, but it comes from the Latin for key, because apparently the first keys were made out of clavicles way back in the day, which is kind of weird, but that's why it's called that. Okay, and then the scapula. So I'm only going to talk about 2 more bones: the scapula and the pelvis. And I cut away most of the important stuff here. The parts that you need to know are the acromion, which is the crow's beak. I talked about it yesterday. It's this point on the very lateral edge of the scapula. Coracoid process, which is kind of coming around in front. That's the superior border. It's not that big a deal. Here, looking at the lateral edge, you see the acromion and the coracoid process. Then this glenoid cavity, this is where the humerus, the head of the humerus, is going to articulate. The only other thing here is the spine, the scapular spine. So let's look at that from behind. When you look at the scapular spine and you put your hand along the back, you'll feel this bony ridge that runs along the back of the scapula. That's this scapular spine. It divides it into two compartments, the supraspinosus fossa and the infraspinosus fossa. Fossa just means a cavity, like a space. A fossa is like a depression in the bone. This is where the rotator cuff lives. Your rotator cuff is the supraspinous, the infraspinatus, and then the teres major runs through there. Yeah, spinous process. Okay. Humerus, that's what it looks like. Ulna and radius, that's what they look like. You guys know those bones already. Okay, so just a few features of the hip bones. So the hip bone, also called the innominate, is actually made of 3 bones. It's 3 bones that have fused together. And for Christmas, I cooked a ham like hack or whatever. It was like a pelvic bone of a pig. And then for New Year's Day, I boiled the remnant down and made some black-eyed peas because it's good luck on New Year's Day to do that. And in so doing, boiling this bone down, it was really cool to me because I could see the suture in the bone where all 3, the ilium, the ischium, and the pubis in the pig, all came together inside this thing called the acetabulum. We're actually not radically different than pigs or most other mammals. Yeah. So this hip socket is called the acetabulum. Does anybody want to venture a guess why? This is going to be a little bit obscure maybe. But look at the first few letters, A-C-E-T-A, or maybe just A-C-E-T. What word have you seen that starts A-C-E-T? Maybe you saw it in organic chemistry? I don't know. What's that? An acetal, right? Yeah. So without getting too deep into the chemistry, how is an acetal related to another structure, a more oxidized structure? How about something that not people in organic chemistry would know? Like someone in a kitchen might know. Acetone, that would be more like, yeah, you guys are all dancing around the carbon backbone, but actually I'm talking about acetic acid. It's the same carbon backbone, right? And acetabulum literally means from the Latin vinegar bowl. Vinegar bowl. So acetic acid is vinegar. Because at the dinner table in ancient Rome, they would want some vinegar to dip some food in or whatever. And a lot of their bowls were made out of copper, right? And if you put vinegar in copper, that vinegar is going to taste super gross, right? So they needed some kind of, but their pottery was not glazed in a way that was impermeable to the vinegar. So they needed some kind of bowl to hold the vinegar. And the acetabulum, they would get the acetabulum from a cow, and it would be lined with cartilage, which was completely impervious to the vinegar. They acted as excellent vinegar bowls without changing the flavor of the vinegar. They would take it and carve it down and whatever, but it had that cartilage still in there, and they used that as a vinegar bowl at their table. So they call the hip socket the acetabulum, the vinegar bowl. All right. What parts of this are actually more important? I boiled it down, but I kind of want to boil it down even further. There's the obturator foramen. That's important for the adductors of the hip. The iliac crest, that's the big swoop of the top. Ischial tuberosity, that is the thing you sit on when you're sitting down, the bone that you actually feel in the bottom of your booty when you're sitting. The sciatic notch is important, the greater and lesser, but important mostly is the greater, because the sciatic nerve is going to emerge through that sciatic notch. The sciatic nerve is really important. It's a nerve that you can judge the size of the sciatic nerve to a very good approximation by looking at the thickness of your thumb. So it's a nerve that runs through your gluteal region that is about the size of your thumb. That's serious. Yeah, sister, I'm telling you. Big nerve. Goes through there, and if you're getting a shot in the booty, somebody's going to give you a shot of some kind of, there's medicine that, antibiotics or whatever, sometimes you get shot in the butt for. You do not want to hit the sciatic nerve because you will mess that person up. It's not fun. So you got to know where the sciatic nerve is, and understanding the relationship to palpable structures will help you identify where the sciatic nerve is, and then not stick a needle in it. Yeah, that's all there. I think I'm done. I think I'm done. So someone was asking me about male and female. I think you were. So the male pelvis has an angle of 90 degrees or less between the two ischial portions of the pelvis, and the ratio of this direction to this direction is significantly different than it is for women, and that's purely because women are tasked with the privilege and burden of bearing children through the birth canal. All right. So, is there anything else I want to talk about here? I don't think so. Well, there's the trochanters. Yeah. This is the femur, and the only thing that I think is sort of important is this part of the bone here. It's the trochanter. When you push into your hips on the side, it's actually your femurs, these bones right in the corner of your hips there. That's the greater trochanter. A bunch of muscles attached to that, all the hip abductors that enable you to do this. It's also where the IT band is. All right, so let's call it quits right there. And there's only like 10 minutes